Hello everyone. In today's lecture, we will see some more practice questions based on the topic maxima and minima. In the last lecture, we had done till question number 18. Now, in this lecture, we will start from question number 19 until question number 24. Right? The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Let's start with question number 19, which says, in the interval 1 to e, the greatest value of x square log x is. So the hint of this question is C. We have to find the greatest value of x square log x in the interval 1 to e, right? So we are given fx as x square log x. First we'll find f dash x, right? First we'll find f dash x and we'll find the critical points. The critical points means where f dash x equal to 0. Here. So we have different critical points. So we will check the values of the function at the critical points as well as the end points, that is 1 or e, right? So out of the total points, we will see at which point the function occupy the greatest value and at which point the function occupy the least value, right? And you can also check whether f double dash x is less than 0 in case of maxima and f double dash x greater than 0 in case of minima, right? So in this way you can approach this question. So you have 10 seconds to solve this question. After 10 seconds we will discuss the solution. Okay, let's move to the solution part C. Given fx is equal to x square log x. Now on differentiating with respect to x, we get f dash x equal to 2 log x plus 1 into x by using product rule. Now for maximum, put f double dash x equal to 0. Clear? For maximum, put f double dash x equal to 0. Therefore, 2 log x plus 1 into x is equal to 0, right? Therefore, critical points is x is equal to e to the power minus 1 by 2 and 0. Now, e to the power minus 1 by 2 is basically from 0 to 1. So, none of these critical points lie in the interval 1 to e. Clear? So, we only compute the value of fx at the end points 1 and e, right? Because the critical point we found is not none of the critical point is lying in the interval 1 and e, right? And we have to check the greatest value of this function in the interval 1 and e only, right? So we only compute the value of fx at the end points 1 and e. Clear? Therefore, we have f1 is equal to 0 and fe is equal to e square. Clear? Hence the greatest value of fx is equal to e square, right? Got it? So the right answer will be e square. Option A is the right choice. Clear? Okay. So let's move to the next question, question number 20, which says, if x is real, the maximum value of 3x square plus 9x plus 17 upon 3x square plus 9x plus 7. So the hint of this question is you have to find the maximum value of this function. Now, the approach we will apply here is, first you will find f dash x by using quotient rule, right? Clear? By using quotient rule. And after finding f dash x, you will put f dash x equal to 0 to find the critical points, right? Now at each critical point, you have to find f double dash x, right? So the critical point at which f double dash x is less than 0 will give the maximum value. Clear? And the point at which f dash x is greater than 0, right? That point will give minimum value. Since we have to check the maximum value of this function, clear? So the critical point at which f double dash x is coming out to be less than 0 corresponding to that point, we will get the maximum value of this function. Okay, so you can apply this approach to solve this question. Okay, so you have 10 seconds to solve this question. After 10 seconds, we can move to the solution part. Okay, so let's move to the solution part C. We can write fx as in the form of 1 plus 10 upon 3 into x square plus 3x plus 7 by 3, right? Therefore, fx can be written as 1 plus 10 upon 3 into x plus 3 whole square plus 1 by 12, right? C. Instead of finding f dash x, we can directly say that fx will be maximum. Fx will be maximum when this function is minimum, right? When the denominator will be minimum, clear? So denominator will be minimum when this square term will be 0. That means at x equal to minus 3 by 2, we can say that fx is attaining maximum value, right? So at x equal to minus 3 by 2, fx is attaining maximum value, right? So we can easily find f minus 3 by 2 is basically 1 plus 10 upon 3 into 1 by 12. We have put x equal to minus 3 by 2. Therefore, we are getting maximum value of function is at minus 3 by 2, and which is after solving coming out to be 41, right? So maximum value of the function is 41. You can also apply that method to find f dash x, right? F dash x to get the critical point, and each critical point you will check whether the function is attaining maximum value or minimum value by checking the sign of f double dash x, right? But that method will be a little complicated, and this method is basically a little easy, right? So you can go by both method, but I have discussed the easy one, right? So I think option A is the right choice. Got it? Let's move to the next question, question number 21, which says the maximum and minimum values of fx is equal to sec x plus log cos square x at from x is equal to 0 to 2 pi r respectively. So we have to find maximum and minimum values of fx. So you can apply the same procedure. So the hint of question is, first you will find f dash x, right? F dash x, and put f dash x equal to 0 to get the critical points, right? And at each critical points, you will calculate f double dash x, and you will put the f double dash x, you can find f double dash x at each critical point and check the signs of f double dash x. If f double dash x is less than 0, then the function will attain maximum value, and if f double dash x is greater than 0, then the function will attain minimum value, right? And C, we are also given this interval 0 to 2 pi, clear? So you have to check at the endpoints also, right? At x equal to 0 and x equal to 2 pi. So in this way, you can reach to the results in this question. Okay. So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Given fx equal to sin x plus log cos square x. Therefore, fx can be written as sec x plus 2 log cos x. Therefore, f dash x can be written as sec x tan x minus 2 tan x, right? Therefore, f dash x is equal to tan x into sec x minus 2, right? So f dash x, if f dash x equal to 0, if we put f dash x equal to 0, therefore either tan x equal to 0 or sec x equal to 2. If sec x equal to 2, therefore cos x equal to 1 by 2, right? Therefore, the possible values of x are basically x equal to 0 and x equal to pi, and x equal to pi by 3 or x equal to pi by 3. Again, let's find f double dash x. So f double dash x can be calculated as sec square x into sec x minus 2 plus tan x into sec x tan x, right? So f double dash x will be, after adjusting and simplifying this, you will get f double dash x as sec cube x plus sec x tan square x minus 2 sec square x, right? Got it? Now, let's adjust. It can be written as sec x into sec square x plus tan square x minus 2 sec x. Now let's find f double dash 0. F double dash 0, which is 1 into 1 plus 0 minus 2, which is minus 1, which is less than 0, right? Therefore, x equal to 0 is point of maximum. Clear? Maximum. Because f double dash 0 is coming out to be less than 0. Now, f double dash pi is basically minus 1 into 1 plus 0 plus 2, which is minus 3, less than 0. Therefore, x equal to pi is the point of maximum again. Now, let's find f double dash pi by 3. So, 2 into 4 plus 3 minus 4, which is equal to 6, which is coming out to be greater than 0, right? Therefore, x equal to pi by 3 is a point of minima, right? Because the sign of f double dash x is basically greater than 0. Now, let's calculate f double dash pi by 3, which is 2 into 4 plus 3 minus 4, which is equal to 6, which is again greater than 0. Therefore, x equal to pi by 3 is a point of minima. The maximum value of y at x equal to 0 is 1 plus 0, which is equal to 1. The maximum value of y at x equal to pi is basically minus 1 plus 0, which is minus 1. Minimum value of y at x equal to pi by 3 is basically 2 plus 1 by 2 log 1 by 2, which is equal to 2 into 1 minus log 1 by 2, 2 into 1 minus log 2. Now, minimum value of y at x equal to pi by 3 is basically 2 plus 2 log 1 by 2, which is equal to 2 times 1 minus log 2. Got it? Clear? So, I think option B is the right choice. Okay, option B is the right. Got it? Now, let's move to the next question. Question number 22, which says the difference between greatest and least values of the function f(x) is equal to sine 2x minus x on the interval minus pi by 2 to pi by 2. You have to find the difference between greatest and least values, right? See, again, the hint of this question is you again have to find f dash x to find the critical point. To put f dash x equal to 0, you will get some critical points. And now you are given some interval also, that is minus pi by 2 to pi by 2. So you will also check at the end points, that is at points minus pi by 2 and pi by 2. Therefore, you will check the value of fx at minus pi by 2 and critical points, right? So you will easily get at which points the function is attaining greatest value and at this point the function is attaining least value, right? Okay, so this approach you can apply to solve this question. You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Given fx is equal to sine 2x minus x, therefore f dash x is equal to 2 cos x 2 cos 2x minus 1. Now put f dash x equal to 0. Therefore, cos 2x equal to 1 by 2. So 2x is equal to minus pi by 3 or pi by 3. Therefore, x is equal to minus pi by 6 or pi by 6. Now, calculate f of minus pi by 2, which is equal to sine of minus pi plus pi by 2, which is equal to pi by 2. Now, we can calculate f of minus pi by 6. Critical points are minus pi by 6 at pi by 6. So we will check the value of function at x equal to minus pi by 6, pi by 6, minus pi by 2 and tan 2, right? Therefore, f minus pi by 6 is basically sine minus 2 pi by 6 plus pi by 6, which is equal to minus root 3 by 2 plus pi by 3, pi by 6. Now, f pi by 6 is equal to sine 2 pi by 6 minus pi by 6, which is equal to root 3 by 2 minus pi by 6. And f pi by 2 is basically sine pi minus pi by 2, which is equal to minus pi by 2. Clearly, pi by 2 is greatest value and minus pi by 2 is the least value, right? Therefore, the difference between greatest value and least value is pi by 2 plus pi by 2, which is equal to pi, right? Which is equal to pi, right? So option A is the right choice, pi. Got it? Okay, let's move to the next question, question number 23, which says that the point of inflection of curve y is equal to 5, y equal to x to the power 5 by 2 is 5 by 2 is. We have to find basically the point of inflection. The hint of this question is, see, what is the point of inflection? The conditions of point of inflection is that the dy by dx need not to be 0, clear? And dy by dx is either less than 0 or greater than 0 at x is equal to some point, which is known as inflection point. Okay, so in this way, the same condition you can apply for getting the point of inflection of this curve y is equal to x to the power 5 by 2, right? So in this way, you can apply the concept of this question. So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Given y is equal to x to the power 5 by 2. Therefore, dy by dx is basically 5 by 2 x to the power 3 by 2, right? And d square y by dx square is equal to 15 by 4 x to the power 1 by 2. So we have discussed that dy by dx need not to be 0. But at here, at x equal to 0, dy by dx equal to 0. And d square y by dx square is also 0. And d cube y upon dx cube is not defined, right? Which is the condition of point of inflection, right? So when therefore x equal to 0 is the point of inflection, and when x equal to 0, y is also equal to 0, right? Therefore 0 0 is the point of inflection. Clear? So I think option B is the right choice. 0 0 is the point of inflection. Okay, B is the right choice. Now let's move to the next question, question number 24, which says the maximum area of right angle triangle with hypotenuse h is. So the hint of this question is, see, we are given hypotenuse h. So we can make a right angle triangle and we have to find basically maximum area. Right. So we can write x square plus y square is equal to h square, right? And hypotenuse h is given. Now we can differentiate throughout to get dy by dx, right? Now we will find the inflection point in terms of h, right? Because h is given, and we will find critical points in terms of h. And at each critical point, we will see at which point the area is attaining its maximum value, right? By using f double dash x, by using the sign of f double dash x, right? So you can use this concept to solve this question, right? So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. See, the area of triangle. If it is x, h, this is x, then this term is basically root over h square minus x square, right? Therefore, area of triangle is equal to 1 by 2x root over h square minus x square, right? Therefore, delta is area of triangle, right? Now, delta by del x is equal to 1 by 2 root over h square minus x square plus x into minus 2x upon 2 root h square minus x square equal to 0. So x is equal to h by root 2. As we have discussed, we found critical point in terms of h, right? So at x equal to h by root 2, d delta by dx is coming out to be 0. Now let's calculate d square delta on dx square at x equal to h by root 2, which is coming out to be less than 0. That means x equal to h by root 2 is giving the maximum area, right? Therefore, at x equal to h by root 2, let's find delta, which is equal to 1 by 2 into h by root 2 into root over h square minus h square by 2, which after simplifying you will get h square by 4, right? Therefore, the maximum area of the right angle triangle with hypotenuse h is basically h square by 4. So I think option D is the right choice. Clear? Option D is the right choice. Okay. So in this way, we have discussed different types of questions based on maxima and minimum. Hope you understood the whole concept and how to approach these questions. Clear? Different types of questions. Okay. And hope you liked the lecture. Okay. Thank you so much.